Hello, everyone. Welcome back to day 2 of 12-3 Permutations and Combinations. Previously, we learned about permutations, how to count the possibilities, how to count how many choices we have. Okay, we learned that if order matters, we're going to use permutations. Today, we're going to learn that if order doesn't matter, we're going to use combinations. Let's start with our warm-up. Remember, when you're ready to pause the video, you pause it, you try out the problem, you check, did you get it right? Do you know what you did wrong if you make a mistake? And we keep learning. So if there are 24 students in the final race, how many ways can they come in first, second, or third place? If the top 4 students in a previous heat of 24 students will all move on to the finals, how many groups of, it should say 3, so I should say if the top 3 students, how many groups of 3 are possible? And then I want you to figure out what the difference between those two problems is. So go ahead, pause the video, test it out. When you're ready, we will check the answers. Okay, so let's look at the top one. So 24 students, and I want to decide how many ways they can come in first, second, or third. So order matters there. So we're going to have a permutation. So 24 permute 3. We have 12,144 ways. Now, the second case is a little bit different. The second case, as long as I come in the top 3, I come in first or second or third, I move on. So I have 24 permute 3 ways if the order matters. If it matters who comes first, second, or third. Now what I'm going to do is I'm going to write out all of the different possible orders of how I could come in first, second, or third. So 3 people can come 1, 2, 3, or first, third, second, third, first, second, first, third, first, second, or third, second, first. So there are 6 different ways that these 3 people can be rearranged. So we're counting the same order 6 times. So what we're going to do is we're going to take and divide this by 6. Now we're going to have a special term for this, and it's called a combination. So there's 2024 groups of 3 when order does not matter. Now this was a challenging problem because we didn't know about combinations yet. We knew permutations was order matters, but we're going to learn today that combinations when order doesn't matter. So the difference is, does the order matter? If it does, we're going to use permutations, and if it doesn't, we're going to use combinations. So what we see here is a combination is a set of objects with no specific order. Okay, we're going to take, and I like this formula. The number of combinations is n factorial divided by r factorial times n minus r factorial. And let's show some actual numbers to show how that works. Okay, let's show the last one where we had 24C3. Okay, so we had 24 factorial over 3 factorial. And 24 minus 3 factorial. So what we see is we have this 24 factorial over 21 factorial. Okay, this part was the permutation, and then we have to divide it by what's double counted. Okay, all of the orders that are counted in multiple different ways. So we have the permutation, and then we divide it by 3 factorial, which is the 6 ways we saw previously that we could rearrange 3 numbers. Now we also have a button on the calculator that'll do it for us as long as we understand whether order matters or not. So if we have 8 songs and we want to choose 5 to put on a playlist in order is not important, then we're going to do 8 choose 5, 8 C5. And the button for combinations is right next to the button for permutations on your TI-84. Okay, or we can compute it by saying, well, we got the permutations, so 8 choose 8 factorial over 3 factorial. Okay, that does 8 times 7 times 6 times 5 times 4. And then we're going to take that number and we're going to divide it by 5 factorial because it's how many double counts we have. Okay, so we do the permutation and then divide it by how many repeated counts we have. Or we can just do 8C5 in the calculator and get 56 playlists. So here's an example for you to try. Marisol is planning to be a counselor at summer camp. She can choose 3 of the activities on the right for her session. How many combinations of the 3 activities are possible? Pause the video, go ahead, try it, see if you understand how to calculate how many combinations we have. Okay, so looking at the right, I see archery and arts and crafts, and I see lots of activities. Don't really care what the specific activities are. I need to know how many of them there are. So I'm counting, I'm thinking 10. So since the order doesn't matter, we're going to use a combination. That's always my first thought. Does it matter, the order, or does the order not matter? If it doesn't, 10, C3, because combinations, and 10C3 is 120. And that's all there is to that problem. We're eventually going to use this in probability, but this helps us count the total possibilities. Here's another one. Okay, I would recommend you do it. Pause the video. Okay, let's take a look. How many ways can a camper choose 5 activities from the 10 available activities at the summer camp? When I see this word choose, okay, means make a combination. It doesn't tell me in this problem, well, they want to pick something first, second, or third. It just says pick a group of 5. Lots of words in these word problems tell me whether order is going to matter or not. So 10 choose 5 is 252. Okay, and I hope 10 choose 5 is 52. But that could have been a mistake on my part. But we have to do 10 choose 5 in calculator. Now here's a challenge for you. This is going to include the probability. Teacher chooses 5 students at random from the names shown to work together on a group project. I want to know the probability that 5 students' names all begin with constant. So try it out. Pause the video. If you need some hints, I will go through the answers momentarily. Okay, so here's some hints if you haven't finished this problem yet. How many different ways can we choose 5 of all of the students? And then how many ways can we choose 5 of the students whose names begin with a constant? So let's look at this. First thing we need. Okay, order doesn't matter. I always like to state that and say I'm using combinations or I'm using permutations. So I see that there's 18 students here, and I want to choose 5 of them. So that's my denominator. There's 8,568 ways to pick the 5 students. That doesn't factor in what their name starts with or what their name ends with. Now, there's 13 of these students that their names begin with consonants, so not a vowel. Maybe we forgot what consonant means, and that's unfortunate. So, a bunch of people whose names begin with consonants. And now we make a fraction. So the probability that we've picked 5 students with consonant names is 1287 over 8568. Now we can simplify it if we want, convert to a decimal, maybe for some reason we want to make it a percent. But probability is a fraction, part over whole. And we use combinations to figure out the part and figure out the whole, how many options there are in this case. Now here, and I simplified it, I made it a decimal. Depending on what the problem's going to ask is what I'm going to do with it. I might even leave 1287 over 8568. Okay, that's a fine fraction. It means the same thing. Now here is another one for you to try if you'd like. Probability that the 5 students, that you choose 5 students and their names end with a vowel. So pause the video, test it out, see if you got it. Okay, hopefully you tried it. So let's take a look. Okay, still using combinations. The denominator is still the same. Okay, still have the same 18 students, and we're choosing 5 of them. So that's my denominator. But now I got to count how many students' names end with a vowel. I counted 12. So 12 choose 5. There's 792 ways to pick 5 vowel names. And we make a fraction once again. So if you can find the numerator, find the amount of combinations for the numerator and combinations for the denominator, you've made a probability problem. You can make a fraction. You can convert it to a decimal. The whole goal here is, can I use combinations and permutations to count the number of possibilities? Because these are more than just, well, there's 6 numbers on a die, or if I flip a coin, I got 2 possibilities. Now I got lots of possibilities. So, major idea here. Permutation order matters. Combination order doesn't matter. Okay, we can use the permutation button, which does this calculation. We can use the combination button, which does this calculation. Okay, combination is just a permutation divided by all the repeats. And that is permutations and combinations, which are very useful for counting possibilities.